where f1 and f2 are functions that satisfy these two, right? Okay, that's the first thing I talked about yesterday. The second thing I talked about is this one. If fx and fy belong to the Gumpel max domain of attraction, then G can also be expressed in this form, where K is a function on the real line that satisfies these 5 conditions. The limit as t goes to plus infinity is 1, t goes to minus infinity is 1. This derivative is negative or less than or equal to 0 for all t. This derivative is non-negative for all t. And this expression is non-negative for all t. Okay. So these two representations, this one and this one, are equivalent to each other. All right. Okay. And the third representation I talked about is this one. That is, if fx and fy belong to the Frechet max domain of attraction, then G, the possible forms for G, can be expressed in this form, where A is a function from the unit interval to the unit interval satisfying these 4 conditions. Right, the A of 0 is 1, A of 1 is 1, and A of omega must be between these two for all omega, and that A is a convex function. Okay. Then I showed you, then I gave you a condition how to check a function is convex if and only if the second derivative is positive for all x. Okay. Okay. Then I gave you this right here. If the margins of G are unit exponentially distributed, that these are the exponential margins, then the possible forms for G bar can be expressed in this form, where A satisfies once again the same conditions. Okay. And finally, this is an open problem for you to think about. I'm not going to ask you this in the exam. It's something you may think about in the future, right? Okay. Especially if you guys want to pursue PhD or higher degrees, you may want to think about how to solve it. Then I did a few examples. This is one example I did. This is one example I did. This is the second example I did. Okay. This is the second example I did. Then I also did a third example, but this one is a different kind. This example I did yesterday was on trying to find the G corresponding to this, right? I made a very small error. I don't know whether you guys copied this down or yesterday, but in the version that I put online, the scanned version, I corrected the error. I think this thing here should be 1 over Q. This should be 1 over Q. This should be 1 over Q. And this should be 1 over Q, but the result is the same as what I got yesterday. So if you had copied it down yesterday, please correct it. If you can look online, you will see the correct version. If you look at what I did, what I scanned and put online, you will see the correct version. Okay. Alright, so today I'm going to do more examples. So I'm going to start with example number 4. Example 4. Okay, so I mean, this is one of the questions in the problem sheet, but so this is so we need to first of all we need to decide on which of the 4 or 5 representations we need to use, right? To do that, you need to work out the margins. You can see from above if you put y equal to 0 into here, you will get exponential of minus x. And if you put x equal to 0, you get exponential of minus y. So the marginals are exponentially distributed. So we need to use representation 4. Okay. Alright guys, do you follow what I've done? So you first work out the marginals of G bar. What turns out to be this and this. So clearly the marginals are exponentially distributed. So we will use representation 4. Okay. By the way, today is the last lecture, because next week we will have revision class. I think I told you this yesterday, right? I said this yesterday. Next week we will have revision classes. So any questions you guys have to prepare for the exam, please bring it next week. Or you can even come and see me anytime, to clear things up. And I also sent an email last week about the stuff you need to know for the exam. Did you receive that email? Yes? Yes? You check your email or not? You delete all my emails. I sent you guys an email last week, all of you, about the stuff that will be in the exam. All right. Anyway, so the first thing we need to do is we need to determine the A function. So we can write you need to pull the x plus y in order to work out the A function. Yeah. So you can write G bar in this form. So this implies that your A function A of omega is equal to 1 minus W of omega, W per omega. Okay, this is what you got. Okay. Okay, now we need to check the 4 conditions. Remember the 4 conditions. The first condition is that A of 0 is 1. The second condition is that A of 1 equal to 1. The third condition is that A must be between the max of omega and 1 minus omega and 1. And the condition number 4 is that A must be a convex function. Okay. So let's see how we can check. So condition 1, A of 0 is clearly, if you put omega equal to 0, you get you get 1, right? And the second condition is A of 1. If you put omega equal to 1, you get get this. Okay. Is that clear? Okay. And condition number 3. So we are done with the first two. Okay. The next one. We need to check whether the max of omega, 1 minus omega is less than or equal to this. It's less than or equal to this for all omega. Alright? We need to check this condition is satisfied. To do this, this is the same as doing this. You need to check 3 things. 1, this, and 2, and 3, okay, so you need to check each of these 3 guides, right, in order to prove that thing, right? So we will start with the number 1, which is A of omega is less than or equal to 1, right? So let's see how we can prove that. Now, so let's call this okay, we'll start with 1, right? Now, we know that A is a number. I think the question says that A is greater than. It says that A is greater than or equal to 1. Right? I should have mentioned that A is a number that is greater than or equal to 1, right? Which implies that W of A, omega of A must be less than or equal to omega. We know that because remember, if omega is a number between 0 and 1, so the higher the power, the smaller it will get. You know? So since the number A is greater than or equal to 1, omega to the power A will be less than or equal to omega. Right? That's because omega is a number between 0 and 1. So when you increase the power, it will get smaller and smaller and smaller. Yeah? Okay. So this implies okay, and this implies and this implies that A of omega so we have proved that A of omega is less than or equal to 1. Is there any questions on this so far? Hello guys, are you with me on this? Yes? Okay. And the next thing we need to prove is part 2. We need to prove that A of omega is greater than or equal to omega for all omega. right? So that implies, that's the same as saying okay, that's the same as saying this, right? Okay, and these two guys cancel. So okay, so we have proved the second condition too, right? So starting with this is equivalent to this, but this is always true because omega is between 0 and 1. So this is always true. So this must be true too. Okay. Okay, guys. Any questions so far? Let me know. And part 3, is similar to part 2. We want to prove that A of omega is greater than or equal to 1 minus omega for all omega. Okay, so that's the same as saying that this, yeah, and this is the same as saying, well, and this is the same as saying alright, so we have also proved part 3. So we have proved condition one, part 1, part 2 and part 3. So hence we have shown okay, so hence we have shown that A of omega lies between this and this for all omega, right? So the only thing that we haven't done is to prove the last condition, which is that A is a convex function. Now how do you show that something is convex? Take the second derivative. So let's see if we can prove that. So to prove convexity, we need to take the second order derivative. So first we need to take this first order derivative. So let's take the, so what's the first order derivative? It's going to be 1 over A multiplied by, correct me if I'm wrong, I often make a lot of mistakes, but what's the derivative of this with respect to omega? A times minus 1 plus A times like this. Alright, so this will be, the A will cancel, so this will become multiplied by so this is a right. Correct me if I made any mistakes. If I made any mistakes, let me know, please. Is that okay? Okay. That's the first derivative. Now, the second derivative, the second derivative is going to be there will be an A here, and then multiplied by this, and then there will be A minus 1 here, so it's going to be plus A minus 1, and then if you differentiate this, you get multiplied by then minus will be plus, this will be plus 1 minus W to the power A minus 2. Alright, this is what you will get. Now you need to simplify this thing because it's not going to be easy. Alright, we will see. Alright, let me go to the next page. Let me know if I made any mistakes, guys. This is right, guys. Let me know, please. It's possible, it's quite possible there may be an error. Okay. So if you simplify this, guys, you get A minus 1 is a common factor. Then alright, this simplifies to the following: is A minus 1 is a common factor. Yeah. And then you have this, right? Okay, and then multiplied by okay, and then you have plus okay, this is what you get. Okay, so I think if I made a mistake, please let me know, but this is what I am getting, right? Okay, so now we need to prove that this is positive, right? Is this right, guys? So if I made a mistake, yes. Means over here, here. Yeah, it should be 1 over a, yeah, because the power here.
No, I mean the outside the bracket.
This one.
The left of what you have planned. 1 over a times bracket 1 over a minus 1. It's like on the top of the first derivative is just 1 over a.
Which one? This one. Oh, over here.
It's okay.
Is it okay?
No problem.
It's okay.
Is it okay?
Yeah, it's fine.
Okay. So this simplifies to is that right, guys? Hello, my friend. Is this correct? Yeah. What about you guys? Yeah. Is that okay?
Yeah, right.
Okay. Okay. All right. So let's see how we can show. Now, if we assume that a is greater than 1, then this guy is positive. This 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 whole thing is positive. This is positive. This is positive. And this is positive. So hence this must be positive for all w. Right? Okay, so hence A is convex. So hence is that clear, guys? Because all the terms. No, sorry. I shouldn't have said that there's a minus here, but it doesn't matter what the minus, because you're taking the square. You see, you're taking the square of this. You're taking the square, so this must be positive, because you're taking the square. This must be positive, right? And all the remaining terms are all positive, right? You see, because this is power 2, right? So it must be a positive number. this is positive, all these are positive, so the function must be positive. Is that okay?
But when we factorize it, shouldn't the negative sign be outside the square? Because from there, it's a into 1 over a minus 1. That's 1 minus a. And here a minus 1 is outside.
I mean here,
No, the first
first term.
term in this. It's a times 1 minus a minus 1. It's 1 minus a and not a minus 1.
Oh, okay. Oh. Should be 1 minus a, yeah. So I see what you're saying here. There should be. I didn't see that, yeah. So that means it's not right. Oh, no, yeah, it should be 1 minus a. So whereas this is a minus 1. So
It's okay if we just add a negative sign there. If we just add a negative sign.
yeah, but if it's a negative sign, then it's difficult to prove.
Yeah.
How can you prove that if there is a negative sign? Things get complicated. Alright, let's see. I mean, this is going to get complicated. Sorry, I think you're right. Yeah, you spotted a mistake. I think what I did is not. So this is wrong. This whole thing is wrong. We need to start all over again. This is what. So this. Sorry, guys. So from this. Did I do this correct? I mean, what you have is equal to 1 minus a, okay, times plus a minus 1 Alright, we need to show, okay, suppose this is okay, suppose this is positive for all w, right? Okay, that would be the same as saying, so that would imply if this is positive for all w, then that would be the same as saying that If you spot any mistakes, please let me know. I mean, okay, the same as saying this. Now a few things will cancel. So now if you divide a minus 1 and a minus 1 will cancel, right? And also you can divide this into this. You can divide this into this. So to get this would become like this. Correct me if I'm wrong. This would become okay. This would become like this. Now let's expand the left this side here and also this side. So if you do the expansion, this will become I have to be careful in the expansion. So so this will become like this is minus 1. So 1 minus okay, like this. I know I'm squeezing things in, but this is what you get, I think. Once again, please, if you spot any mistakes, please let me know. So a few things will cancel out. This will cancel with this will cancel with this one. So you get this to be the same as this to be the same as plus alright, this is what you get. Okay, so but this is always true because did I make any mistakes, guys, so far? This is always true because this guy here is positive, this guy here is positive, and this guy here is always positive. So this right, is this correct now? I don't know. I hope this you see what I've done. or not? Is it? I hope this time is correct, because the last time it was not correct, because you see what I've done. I have written this guy like this, and then I assumed that this is positive. Assumed this is positive for all omega, right? By assuming that you can write this as this, then a few things will cancel. These two will cancel, and this you can divide by this, so it becomes like this. This becomes like this, and finally you get this. Finally you get this, which is always true, which is always positive, right? So hence A is a convex function, and hence G bar corresponds to the bivariate extreme value distribution, right? Okay, guys, it's a long process. I know it can be confusing. And any questions you guys have? We will just, no? Guys, you have questions, guys? Hello, sir. Everybody watching the what? The iPhones. All right. The next one. I think we'll take a break in 5 minutes time, but before that, I'm gonna give you a problem. So this one, I'm sorry, I'll throw this away. I made a mistake. I'll throw this away. Okay. So this is example 5. All right. All right. So you know what to do, right? So the first thing you need to do is to find the marginals, and then decide on the representation to use. There are 5 representations, right? Okay. So first, so if you put y equal to 0, you get exponential of minus x. And if you put x equal to 0, you get exponential of minus y over 3. Then you get minus y over 3, and you get y over 3, which is equal to exponential of minus y. So both margins are exponentially distributed. So we need, once again, we need to use representation 4, right? So the first thing you must do is to find out what the function a, capital A, is. Okay. So I'm gonna write g bar x comma y as follows. So I'm gonna pull out x plus y. So if you pull out x plus y, you get the following inside. Okay, this is what you get. Okay. Yeah. So this implies that a of omega. This implies that your a of omega is equal to 1 minus omega plus. You guys okay? Okay, so this is your a of omega. So it's 1 minus omega plus omega over 3 plus omega squared over 3 plus omega cubed over 3, right? Yeah, so now we need to show that this satisfies the four properties, all right? That's what you're going to do in the tutorial today. And before the tutorial, when we move to the next room, I've wrote some notes for you guys. Thank you for completing the unit evaluation. I think all of you have. I'm happy that all of you have done it. All the 15 students in the class. Alright, so you take a 10-minute break now. After that we will go to the next room. Okay? So can you fill in the attendance sheet, please? The attendance sheet.
I'm not coming to the tutorial. I'm going to have a bit of a break.
Okay, sorry.
I'm not going. I won't be here next week as well because I'm going home this weekend.
Okay.
I'm flying back already, so
Okay,
I won't be here next week.
Okay, have a good time then.
Thank you.
And for any questions, just email me.
Yeah.
Yeah. Okay, thank you. Bye. I'll see you guys in the next room, okay?